All right, YouTube peeps. It's Bob N1 KPR, and I wasn't going to do this video today. I had some other things cooking, but I said, let me look outside. And I went out and fed the birds, and the raccoons, and the squirrels, and the chipmunks. Everybody's out there eating. Everybody except me. And I noticed that it was very dark and cloudy and cold and damp, and it's Sunday. So I said, you know what? I'm going to go to the shop, and I'm going to do the end of this direction finder thing that I thought it would take 2 more videos to finish it and show you guys, but we did it all in one, and this is the last one. And we'll link them all together right down there below. See? Right below. Right. Where's it? Down here somewhere in the notes. Go look at it. I'm using the this thing that there's a video here on this thing, the AMZ1 receiver, because it was handy, and it gives me a good indication of how we're doing the signal level here. So, and we have the meter. So let me get into it really quick, because you know what Bob does here. He gets all off in the weeds. We ended up with, if you look at the first and second videos, I think there's 3. I don't remember now. But anyhow, there's a whole family, and they're all linked together. Take a look. You can go backwards from here. Signal input, I've got an off position. The direction finder, RDF thing. You'll see how this thing was made and, you know, all that. I got a reference position, which is an external antenna. Let's go around back. I got this thing coming in. This is a, what am I hooked up? Oh, I'm connected to the 160 wire antenna. It's up 35, 40 feet outside. So it's a good reference. Good, nice receiving antenna. And we got a BNC coming down from the RDF down into the, you see that, down into the receiver. Yeah, that's pretty much it on the back. The speaker connection, we also have line output, pre and post line output on the receiver. So, all right, here I go drifting again. I put a shunt level on the reference antenna, only because you could overload whatever you're going to do, and I wanted to balance it off with the RDF, because maybe, just maybe, we could use it as some kind of, differential. I don't know. I want to play around with that. But using 2 different antennas to null out noise and to get a better pattern and all that. I've played around with that stuff before. But there's videos here on that. As a matter of fact, I built a unit that would use diversity antennas, and look that up. It's kind of interesting. I had a lot of fun with it. It's a lot of knob twisting, but when you're in there trying to pull out the weak guys and the DX stuff, man, it works. I was using the 160 or 80 meter dipole and the vertical, and mix and match and twisting the phase around and all that. And you'd be surprised what you could do. I have no idea what the screwy pattern looked like, but I was listening to some stations in India and far off in Asia, a couple in, I think there was one in Australia, if I remember right. Anyhow, drifting again, Bob. All right, so we got a level control on the outdoor antenna so that we can mix and match with this thing and see what we could do with changing the pattern and all that. Purely experimental, but if you don't need it, you don't touch it. Now, the technical part, when you're playing around with proximity loops and things like that, don't forget, you have a receiver that's plugged in with probably with a 3-wire cord. It's going to the house ground system. The chassis on your receiver or your transceiver is cold to ground. It's grounded through the AC line. And you probably got the coax coming out, going to your antenna, and that's grounded somewhere out in the yard, isn't it? Maybe the 2 are bonded together, like at my house. I have the TV, telephone, and the power service all bonded together, all the grounds tied together. That keeps lightning differentials down to nothing, hopefully. But now we're building this thing Do we want ground loops? Ground loops mean you're going to pick up noise, or you're going to get hum, or you're going to get something funny. So and I'll show you this inside, each section of this unit could be either common mode, or balanced mode, I should say, fed from each section in a balanced way away from ground, no ground. Or they could be brought down to the common side where they're all tied together to a bus. Or they could remain off in the balanced position. I did that for the DF antenna, this thing. I did it for the auxiliary or the remote antenna. On the back, that connector back here is floating. It's not floating to the radio, but it's floating as far as the entire system ground is concerned. Also, the receiver connector is floating. It's balanced within itself to the system. What does that mean? Well, it's got the center conductor and the shield going everywhere they should go, but they're not all connected to the common bus. And the common bus would be the power supply and the mains ground to this unit. I'll show you inside. It'll be a lot clearer. The pickup coil in this doodad here, the pickup coil, I'm running it to a reversing switch with an unbalanced loop here. If you remember in my other video, the resonant loop is dead center and then off to one side, and I forget which. I have the pickup coil, which is about 5 microhenries, 3, 4, 5 turns of wire off the end, which is the 90-degree differential from the center to the end. You know, the voltage current thing. It produces a lopsided pattern. Not very bad. The pattern's pretty much figure 8 off of this thing. But it's a skewed 8, and one side of the 8 has a bigger lump than the other. I think if you're writing the number 8, maybe the bottom circle is bigger than the top circle. That's what I got here. So I put in a reversing switch. So if the antenna's here, and I flip this switch the other way, it's the same thing as having the antenna here. See? Here. I don't have to come and turn it to say, oh, which side of the ugly loop, the disconfigured loop is best, this way or this way. I don't have to do it. I can just come over here and flip the switch. All right. Excuse me. I also built in a little preamp so we could come right off the pickup coil with drive level. I don't know why. It's not that much voltage coming down the line from this pickup coil, but I do for calibration purposes. You keep it wide open, or you could drop it down according to the dB level, and it's accurate. You know, -6 is -6. It's half the voltage. The preamp gain is here. I also added a ratio thing, so as you can see, if you're at +6 dB, you're at 2 to 1, and so on, all the way down to, if you can see, 15, and the ratio of 6. Or you just bypass it, leave it out of the circuit. Here's the tuning. Interestingly enough, if you picture the AM band being, let's get here, say 530 kilohertz down here, and over here, 1700. Well, I call it 2 megs. And I'm calling this 400 because that's where it goes. If you picture that band in your mind, you would say, well, 1 meg. Where am I? 1 meg is probably here. Well, believe it or not, it is. No, Bob didn't design it that way. That's just the way it worked out. I guess I got lucky that day. And the logo, I had some extra room, and here, all right, hang on to your hats, guys. If the prototype works out, on the next one we're going to put this on a gimbal, as one of my followers. Thank you. I don't remember your name, I'm sorry, but it's in the comments below, one of the first comments I got. Bob, can you change the angle so this tips up? Yep, I got a gimbal mount, and I'm going to do that, the next one. It's going to rotate around there. See how it goes around like that? And we're going to have a gimbal mount here so we can change the angle from completely vertical back to horizontal. We're going to do that. And I'm going to go you one better. And I told you, hang on to your hats. I'm going to put in here width and depth control. Well, the depth control is actually a peak control. This thing tuning is so sharp, the Q is so high, that we may want to change the width control of the passband, and we may want to change how high the peak is. I'm playing with those. More knobs to turn? Hey, that's radio. That's what makes it fun. This ain't SDR, baby. These are knobs, and they got to be turned. You want good signal. All right, let's just go in. I want to turn the radio up here. I got a guy here, and I'm just going to quickly go through this because the inside's more important. Watch the signal strength here. I'm going to be turning. Oh, if I can get both in there. They're going off here. All right, so we got him. We got him. Oh, you know what? First, let me do this. See if I can peek that up. Hang on a second. I gotta fix some wires here. I had. Sorry about that. I don't know. You plug the wrong wire into the wrong place, you get in trouble. Anyhow, I'm going to tune here. I'm tuning. I'm just going to show you the signal level here. It's at 2119. It may be, I don't know, maybe you can hear it. We're going to go up. We went through the center.
Important happening right now. I'm Jack, that's Miles.
Now, I'm going to try to get both in. I want you to see how touchy this is.
When you cut those kids open, you see rings of sodium inside their DNA.
So, maybe that width and peak control, like we used to have with the old Q multipliers. Remember them? The old Hammerlins and... one of my favorites, the Allied R100 and 100A. What a nice little receiver. They had the Q multipliers in there, and you could do the width and depth and all that, peak and all, and really cute stuff. All right, so that's basically what this does. I don't want to, you'd really have to play with it and get the feeling, but it does work. You turn this guy, max out the signal. If you want to find exactly where the station is, just turn it to the null. I'm pointing toward New Haven now. Which way, I don't, it's off of here, but it doesn't matter from this side. And then I know exactly where to go. I think I'm going to print a compass rose card here, put it on some plastic and glue it down. Like my little logo there, see? I'll put it up there with the degree marks, and then you have this setting in your cabinet that this thing ain't going to move, and then you set the rose to 0, or to north, north is 0, from your listing position. And then you could say, oh, yeah, New Haven, I want to go 95 degrees. You want to go east a little bit. So, just for grins and giggles. All right, let's pull this puppy apart. You're probably half asleep by now anyhow. Hang on. All right, we're back on the air here. Oh, I don't know if I explained to you. Finished with this switch. Focus. Come on, baby. Hang on. Yeah, you're not going to do it, you creep. Look at that. Anyhow, I have the DF position. You're going to have to read the blurred thing. I have the reference position, and then I have a both position. And that way you could do the diversity stuff. You could listen to just the reference antenna or the DF or mute everything. I don't know if I covered that in the beginning. It's kind of focused. All right. Inside. Remember we were talking about the grounds? Or try to get a good view of this. I brought in, I'm going to turn off the glare. I brought in over here B plus, so I could, you know, have nice short lines. This is the mains ground, which is everything. Oh, by the way, I've got a filtered input here because I want everything to be as clean as possible. Very nicely regulated 9 volts for the BB112 varactors. We have Pi network here to further smooth this out. This B plus VCC here is less than 1 millivolt of noise and ripple on the line. Damn near a battery cleanliosity. Super clean for radio work. Less than a millivolt. Line noise coming in. You know, somebody's running a power drill or your furnace motor kicks in or something. Clean it up with that sucker. Transformer that's way overrated, underrated, overrated. Good for a little better than an amp, and I'm drawing a few milliamps, so we're about 300 to 1 under what we need. Of course, you saw this in the other video. The varactor tuning circuit that comes back here to the tuning knob over here. That guy. All right. So the varactor ground, let me use my finger, is this thing. And it can or cannot, I'm sorry, this is the mains ground. The varactor ground is here. The rod for rod antenna. It may or may not be connected to this depending on how you set the switch. Here's the aux antenna input coming from the aux. And the output to the receiver. Notice they're not connected to ground there. Here's an SL239, the B and C for both. They're common here, but there is no ground. The coax brings the ground over to the switch. And it's going to be hard to see, but I'll post this. I have a schematic here. Maybe I'll give you a screen grab of that. And the pot for the attenuator for the outside antenna. Here's the 3 grounding switches. Notice there's a bus wire here, and it goes down. Get that glare out of there to the mains ground. So each one of these switches controls whether it's the receiver, the aux, or the rod that you're tying into the common mains ground, which is the house wiring and every other damn thing around. It's connected to the green wire in your house. Again, you're working with RF ground loops and things like that or something. You got to avoid them. Here's all the finished hardware. Well, I think we covered this in the other video. It works very nice, especially with the felt washer under this washer, the new clamping system, the new stop pin, which allows me almost 360 degrees. This little clamping circuit bracket I have here to keep the wires away from the getting pinched here. Plugs so that we could pull the cover off and work on everything. What else? Oh, coax interconnects all over. I'm using RG174 everywhere. Well, here's some 188 or whatever you call this stuff. Very nice stuff to work with. Very, very good with these kind of short runs. So that's it. I think we covered it all, but I wanted you to see the inside in case you're going to make one of these. Do yourself a favor. Bring the power supply ground in on its own line. This is copper tape. You can buy it anywhere, eBay or anywhere. And in that way, you can actually feed the varactor control voltage as a balanced voltage, plus and minus. It doesn't know there's a ground until you come over here and flip the switch. And when you're listening to your radio and you've turned this thing around and peaked the signal, and then you come over here and you say, well, it's a little noisy, or maybe it could be louder. You can start playing with the grounds. Bring one side of the pickup coil to ground here, or reverse the polarity of the pickup coil and try it again. If you're not using an outside antenna, ignore this. Should the receiver be tied to ground? Do I have a ground loop between my coax interconnect from this thing to the radio, to its chassis, and also through the power line, the green wire running around your house? Is that a ground loop? Well, you're going to find out by flipping this. I can't wait to start the next one. Yes, I could. I think I need a break. There it is. I had to cut a hole here because the transformer is about 1/8 of an inch too high. This will still slide into a rack, but it's the transformer. The top of this is going to be flush with the top of the cabinet now. So there it is. Quick and dirty. Any questions, ask. If you like, give me a thumbs up. Where is it? Right here. Look at, where is it? Yeah, thumbs up is right there. And join the channel. We're going to have more exciting stuff. Go back, look at some of the oldies. We made some real big screw-ups. We made some little screw-ups. We had some success. And we had a lot of fun. Anyhow, we don't leave a project broken or not working properly. We keep at it until we fix it and get it working the way we dreamt about it. In bed, laying at night, in bed, trying to fall asleep. Say, you know what I'd like to do? And it develops from there. Oh, I wanted to show you this schematic. This is all scratched out and everything. If you want to build this, very simple. In the other videos, you'll see all this stuff. Here's how I did the, you see how I did the switching for the preamp? All right. And you see the little X? There's an X. There's an X. And where's the other X? Over here. That corresponds to that. Grab that if you want to see, if you want to reproduce the schematic. That corresponds to this switch. That's all it is. So you could affect the DF, the external, or both, or the off position. That's an option. You don't even have to build it in. The main thing is get this part working. Put the pickup loop in. I really advise putting in a reversing switch here, and you can go right into your radio on your merry way. Here, if you want to add the external antenna, you can do that. If you want to put a preamp in, you can do that. Not necessary. Don't let that stop you. Just build the with using varactors and a rod, and that's it. You could actually do this on a breadboard. If you had the rod, you could wind it some afternoon, put the pickup coil on the end, put the varactors on a little PC board with a 9-volt battery, and you're off and running. So, okay, wait long, Bob. Hey, listen, Happy New Year. I didn't get to say that yet. Happy New Year to everybody. Hope 21 is a good one for everybody. Stay safe. It's Bob, N1KPR is the YouTube site. And www.bobsamerica.com. Send me an email if you like. My email's up there too. Bye-bye. Thank you. Have a good day.